our quiz 6 solution for Math 243. This first question here is the 8.2 question. We're assume that 60% of Americans think Barack Obama will get reelected. That is P equals 0.6 or 0.60 if you prefer. Let's see, we have 80 Americans chosen at random, N equals 80. And we need to know what is the probability that less than half, so P hat equals 1/2, in other words 0.5, think that I'll get reelected. And then it's this hint here that says be careful, make sure you check to make sure the sampling distribution is approximately normal. So maybe I should do that first. Test if sampling distribution is approximately normal. See, the test for that is if n times p times 1 minus p is greater than or equal to 10. N is 80 in this case. P is 0.6. 1 minus p is 0.4. Oops, that's greater than or equal to 10. If you stick that in a calculator, 0.6 times 0.4 times 10 gives you, 0.6 times 0.4 times 80 gives you 19.2. This has to be greater than or equal to 10, and sure enough, 19.2 is greater than or equal to 10, as you'd probably expect, because if it wasn't, we couldn't even do this problem. But you need to write something like this to show that we can even do this problem. And then once you do that, really what we need to do is figure out a z-score. And I guess to figure out the z-score, we need to know what the mean of p hat is and what the standard deviation of p hat is. Kind of hard to write. The mean of p hat is just 0.6, and the standard deviation of p hat, we got a formula for that. It's the square root of p times 1 minus p. Maybe I'll write 0.6 times 1 minus 0.6 divided by n, which is 80. So let's see, if you plug in 0.6 times 0.4, divide that by 80, and take the square root. What you get is this thing is kind of an ugly number, 0.055, say 0.055. Maybe I'll tell you to round to 3 digits, something like that. Okay, anyways, once you have this information, you can figure out your z-score. Your z-score is equal to p hat minus the mean of p hat divided by the standard deviation of p hat, which is, let's see, how should I do this? I guess I'll use the rounded value, even though I realize some of you using your calculator will use the exact value. But either way, you should get something close to, the z is negative 1.82. And if you know that z is negative 1.82, you can go to your tables. Let's see, maybe I'll draw a picture. There's a pretty poor drawing of my standard normal. I got z is negative 1.82 down here. And what I want to know is what is the probability that we're less than that? What is the area of that shaded region? And I can figure that out by going to my tables. Is 0.0344 is this area. 0.0344. So my final answer, don't really have a lot of room, is the probability is 3.44%. Something like that. Okay, good enough, I guess. All right, the second problem. Here's the confidence interval one. We don't know how far an adult male can throw a football. We don't know mu, but we do know the standard deviation. We know that this is equal to 16. We know that our sample is 400 people, and we know that x bar is equal to 40, and we have alpha is 1 minus 0.90, which equals 0.10. The other piece of information that you'll need is z sub alpha over 2. So the z-score that corresponds with half of alpha being the area above that z-score is 1.645. And if you know all that, you can write that a confidence interval is equal to x bar plus or minus, I'll write it out this way, z of 0.05 times sigma divided by the square root of n. Plug in the numbers, you get 40 plus or minus 1.645 times 16 divided by 20, which 1.645 times 16 divided by 20, the margin of error is 1.316. So we get that our confidence interval is equal to 40 minus 1.316. Let's see, 38.684 all the way up to 41.316. Whoops, 316. I think that's what it was asking for. Create a symmetric interval around the point estimate that you are 90% sure will contain the true unknown population mean. So that's just a, I don't know about complicated, maybe confusing way of describing what the confidence interval was. And I did that on purpose because I wanted you to kind of understand that that's what the confidence interval meant. Although since you knew the test was on the confidence interval section, maybe you just assumed that's what I was talking about. But at any rate, that's your answer. I'll throw a box around it, and we'll call it a quiz.